My name is Alexis Kinlan, and I'll be hosting today's webinar. The School of Public Policy is Canada's leading policy school, known for practical research and for bringing people together to discuss the important issues with experts, which is what we are here to do today. Thank you all for joining us. If you have to leave early, we post recordings of all our webinars on our website and YouTube channel, and you'll receive a link in the follow-up email. The topic of today's webinar is Shrinking the Hoofprint of Canadian Beef, the Future of a Sustainable Industry. Our speaker today is Dr. Tim McAllister, Principal Research Scientist with the Lethbridge Research and Development Center with Agriculture and Agri-Food Canada. For our format today, our speaker will present for about 20 minutes, and then we'll open it up for an audience Q&A. Please type your questions in the Q&A box below at the bottom of your screen, and I will pose them to our speaker. So I'm now going to turn the presentation over to Tim.
Good afternoon, everybody. Thanks a lot, Alexis. I'd just like to start by thanking the Simpson Center for giving me the opportunity to present some of the work we've done. This represents work that's been done over about the last 5 years. And it really is a collaborative effort. I'll just share my screen here. So does that come up, Alexis?
Hi, Tim. No, we can't see it yet, but I can share on your behalf.
Just let me know when it's up. Can you guys see it now?
Yes, we can. We're good to go. Thank you.
Okay, thanks a lot. Yeah, so this is work that's was truly a collaborative effort. It involved looking at the environmental hoofprint of the Canadian beef industry. So it involved the Beef Cattle Research Council, ourselves at Agriculture and Agri-Food Canada, the University of Manitoba, the Canadian Roundtable for Sustainable Beef provided a lot of direction and recommendations, and we had Environment Canada as well involved in the overall project. So it was really looking at a systems approach to the hoofprint of the Canadian beef industry and how that could contribute to its sustainability. So what's the challenge with the beef industry? Well, it really becomes related to a lot of information that we see, a lot of it coming from the popular press about the contribution of ruminants to methane production. And I always kind of smile when I see this little cartoon where they show the methane coming out of the back end of the animal. Obviously, the person who put this diagram together didn't realize that most of the methane actually comes out of the front end of the animal. So they should have the cow looking like a dragon rather than like a sports car. But anyway, they obviously don't know the anatomy of a cow. But you know, we see these other things where there's work towards meatless Mondays. So don't eat meat on each Monday out of the day. Stop global warming, choose less meat, look at alternative protein sources. There's a number of documentaries that have come out in Netflix that advocate the problems with livestock production and the impact that it has on the environment. One of the later ones was Cowspiracy, and this was actually funded by Leonardo DiCaprio, who paid it. The original producers in that were going bankrupt, so DiCaprio stepped in and paid for the completion of the documentary. And interesting enough, I was involved in a major greenhouse gas meeting in livestock production in Banff in 2010, and we wrote a position paper which basically was a rebuttal to a lot of the numbers in that were being used, developed by an institute in the United States called the World Watch Institute, in which we felt they were using exaggerated numbers in terms of estimating emissions from cattle, including just measuring respiratory CO2 that's released as a result of respiration in the cattle. So we wrote a rebuttal to that, and they wrote a rebuttal to our rebuttal. And in the end, when I saw the credits for Cowspiracy, all of the data that they were using was related to that, what we would call, I'd say mainstream scientists would say, the exaggerated estimates that were associated with that World Watch Institute. So media has a lot of ability to pick and select and project the type of image of livestock production that they want to society to pick up upon. And a lot of it is the issues in terms of understanding that message is that often those messages are coming from special interest groups. As I just described, they're frequently picking the data and generating exaggerated outcomes. And they often are very narrow in scope. They don't understand the trade-offs. They don't consider the benefits and the costs associated with various livestock production systems. And there is no system that's absolutely foolproof, either environmentally or in terms of a negative or a positive impact. It's always about trade-offs. And so that's what we were trying to work towards understanding in this project. Now, some of the points they are making, you know, there is some merit amongst the fiction that's there. There are some facts that they do utilize. You know, it is true that ruminant animals do produce a lot of methane, but we need to understand the dynamics, the interrelationships, and those trade-offs. And then the overall objective then is to provide this information in a non-biased manner so that we empower the public so that they can make informed decisions. Ultimately, the public has the right to make a decision in terms of, in this case, what they eat. But it's really, you know, I think as in the area of policy and science, we want to make sure that those individuals within the public are making those decisions from an informed position as possible. So what is the importance of beef in Canada? Well, there's about 60,000 beef farms in Canada. It's valued to the Canadian economy of about $33 billion per year. We're currently about the 6th largest beef exporter globally. So although our cow herd is relatively small compared to many countries, we are a significant exporter of beef on a global scale. In 2019, we produced about 1.26 million tons of beef. A large portion of that was exported to the United States. And as the world population increases, so does the global demand for meat. Before COVID hit, I was in China several times. And it was quite obvious that there was a growing demand for beef in China. I think much higher than what was originally projected. You know, the main meat sources in China are still poultry and swine. But when it comes as societies become more affluent, if more money is available, they tend to eat more beef. You know, steak is still saw as a select a source of meat in terms of at the dinner table. And I think that was definitely growing in China at that time. The other thing to think about that's important in terms of beef is that beef producers manage vast tracts of land, about 50 million acres of pasture land in Canada. Those help to protect those marginal lands. Many of those lands are not topographically suitable for cultivation, so and they are subject to erosion if they are tilled. Those lands represent a vast store of carbon in the form of those grasslands, and that soil carbon is very important in terms of that store and holding that carbon in the grassland ecosystems. And if we cultivate those ecosystems up, we release that carbon into the atmosphere, contributing to climate change. They're a really important habitat as well for biodiversity, and I'll get into that a little bit more near the end of my talk. And you know, the other big thing is that the grasslands and the forage that you see when you drive around in your cars through the countryside, and you'll see lots of forage fields and grassland fields, that those fields have value because we derive utilizing ruminants to convert that plant cell walls that are in those grasses into high quality protein and for export and for domestic use. So what are the implications of the footprint? Who are we trying to talk to here? Well, you know, given the progressiveness of the Canadian beef industry, I think most of the beef industry is aware of the footprint but where they probably, you know, benefited from the work that we done was in the terms of benchmarking. It's difficult to know how to improve if you don't know where you've been. And also if you don't know how big the improvement is that you've made over time. So that was one of the big things that we wanted to deliver directly to the beef industry in terms of providing them with that information. In addition to that, we wanted to look at gaps or where technology could be implemented to further and result in improvements in efficiency. We wanted beef consumers to be aware of this information so that they can make those informed decisions. And we even wanted vegetarians and vegans to be aware of this information so that they could understand the trade-offs that were occurring as a result of their choice to consume vegetarian and vegan diets relative to meat diets. And there are trade-offs in both directions. So what are the components of the footprint? Well, in the past, the majority of the footprint and most of what you hear in the literature and in the popular press is related to greenhouse gases and climate change, with that focus on the role that ruminants play in enteric methane production, the reduce of methane to the atmosphere. But the footprint is really far broader than that and needs to consider many more components than just greenhouse gases. We need to think about carbon sequestration and land use change. I talked a little bit about how those grasslands hold vast quantities of carbon, and as photosynthesis occurs in each season, those grassland areas are capturing carbon out of the atmosphere and sequestering it in the form of carbohydrates within those plants. There's also consideration for the water footprint that occurs as a result. Water is required for beef cattle production, and I'll get into that in more detail as well, both for drinking, meat processing, as well as crop production. Then there's implications for biodiversity as well. And then ecosystem services in general, which really looks at all of the benefits and trade-offs that come from the production system as a whole. So why did we get involved in this? Well, one of the reasons why we took this on was because if you look at, when it comes to trust of institutions, science is still a major area. Scientists are a major group of which is still trusted in terms of the information that they generate. And obviously, we're held accountable by the laws of science and integrity to go in and investigate an area and collect the data, analyze that data, and interpret that data in a non-biased manner. So it means that you don't go in with any preconceived conclusions. You go in with an hypothesis, and that hypothesis may be either proven or disproven, but you go through that process and you let the data speak for itself and you make that interpretation. That information is also peer-reviewed by our colleagues, both nationally and internationally. And that is the basis of what is published in the recommendations that come out from that process. So that's why you even hear today, when you hear a lot of the policies that are being driven, such as what's going on with COVID-19, you'll hear that many of these decisions, the politicians will get up there and say, well, we're making our decisions based on science-based information. That's what we're using to make our decisions. And that just is because, one of the reasons is because the degree of trust that the general public still has in science. So what is the carbon footprint? Well, the carbon footprint is a measurement of the greenhouse gas emissions associated with human activities, including livestock production. And in this case, we're looking at three gases: carbon dioxide, methane, and nitrous oxide. So methane from the rumen, or the enteric methane, is not the only source of greenhouse gas. Carbon dioxide is also produced as fossil fuels are used in crop production or in fertilizers. And nitrous oxide is also produced typically from manure or also from chemical fertilizers. When they're applied and that nitrogen is not captured by the plant, it can be also released as nitrous oxide. All three of those gases contribute to global warming and to climate change. So we had to estimate all three of those gases, and not only what is coming from the cattle, but also is what's coming from the crop production systems that produce the feed that the cattle consume as well. So those were all part of it. So that's why we need a systems integrated approach that looks across the entire livestock production system, not just the cattle themselves, because you have to consider all components of the production system. So what we did then is we got data from 1981, and we used those years 1981 and 2011 because those were the major census years under the Canadian Census, Stats Canada. And we also had to gather a large amount of other information from other sources, both the scientific literature, as well as the gray literature, as well as through expert opinion, talking to various industry representatives, scientists, etc. From that, then we estimated the greenhouse gases that were produced in those 2 years. We had to estimate the number of animals and the land required to produce that same amount of beef. So those animals and the land required, as well as the feed that was required to produce those animals, were all part of the equations that we used to estimate the total amount of greenhouse gases that were produced. And we based that on the amount of feed that it would require to raise an animal from birth through to slaughter. And then attributed the greenhouse gas emissions associated with that feed production to each of the sectors within the beef production system. Now, one of the reasons why I really like working in the area of beef production and beef research is because it's an incredibly complex system compared to other livestock production systems. And the reason for that is because it's, you know, a large portion of the industry is based in the extensive lands out in the cow-calf sector. That's a large portion of that 60,000 producers that I mentioned. Most of those are cow-calf producers. Those cows and calves are produced out primarily raised on forage, both in grassland systems. So when I talk about the forage that's being produced, whether it be native grassland or tame forage, it's the cow-calf sector that's using the majority of that forage. They're also maintained over the winter months when there is no photosynthesis occurring in crop and grasslands. The cow-calf sector is also maintained mainly on conserved forages in the form of hay or straw over the winter months as well. Now in the fall then, the calves can be weaned, and they can enter a number of different systems after they're weaned. They can either go directly to a finishing diet where they're finished as rapidly as possible in a feedlot, and that typically takes about 16 months. They may go into what we call a backgrounding stage where they're fed a higher forage diet for about 80 to 100 days prior to finishing. Then for about 100 to 120 days, those animals are ready for processing at about 18 months. And then we have what we call the yearling fed group, which is fed over the winter time, typically on a fairly high forage diet with some concentrates. And then they would be moved into a grassland-based system where they would be grazed for a period of time during the spring through to midsummer or so. And then they enter into the feedlot for a finishing phase, which is typically shorter or less than 100 days. And those animals would be slaughtered at somewhere around 20 months. So we have different systems, and the footprint with those systems differ depending upon the type of system that you're talking about. So when we had to do that, obviously, when we look at the cow-calf sector, we didn't have to spend a huge amount of time on cultivated cropland because a very small amount of the feed that's produced goes into maintaining the cow-calf sector from cropland. But when we move to feedlots, then a large portion of that feed comes from cropland, so that represents a much bigger part of the footprint under those conditions. So we had to consider all of those types of complexities when we're developing this overall footprint. So that includes considering the feed types, so the types of diets that are consumed under all of those production conditions, the feeding systems that are used, whether they be intensive systems like feedlots or more like extensive systems like in the cow-calf sector, the cattle classes and numbers across all of those different scenarios that I showed you, their average daily gains, their carcass weights as well. And then those greenhouse gases were emissions were estimated using pretty sophisticated models. Going back to the IPCC, I served on the IPCC in 1996 when we developed some of the first approaches to estimating greenhouse gas emissions from livestock production systems. And we combined that with a model that was been developed in Agriculture Canada called HOLOS, which helps us estimate those and total those emissions up across those various systems. And the mathematics and the assumptions behind those are fairly complicated to come up with all of those estimates and to make sure that they'll stand up to that peer review evaluation that I mentioned by our colleagues internationally. So what did we find? Well, we found that to produce the same quantity of beef in Canada today, which would have been, and today by I mean 1981, versus 30 years ago, it would take 27% fewer slaughter cattle to produce that same amount of meat. 29% fewer cattle are required in the breeding herd. So that means we need less cows and less bulls to produce those calves to produce that same amount of meat. And that's quite significant because there's a significant maintenance cost to maintaining the cows and the bulls continuously, even through the season when they're dry and not producing a calf directly. So that reduction has a significant reduction in the overall emissions associated with the footprint. In addition to that, we found that the beef produced in Canada in 2011 required about 24% less land. So we're being more efficient in terms of that land that's being used to produce the beef or that same amount of meat. We also found that overall carbon footprint, so when you sum up all those emissions from what I described there, was about 15% lower, or 85% of what it was in 1981. When we looked at the emissions as a whole, we did find that methane comprised about 3/4 of the total greenhouse gas productions per unit of beef, and that over 78% of that methane comes from the cow-calf sector. And so that, you know, I think we're not the only group to show that, but other groups have shown that as well around the world. And that represents a major scientific finding that can help promote policy-driven decisions in terms of where we want to focus our future research, our future efforts in terms of lowering methane emissions from beef cattle, and that is in the cow-calf sector. If we really want to make a difference in methane emissions, we need to come up with technologies that will lower emissions within the cow-calf sector if we're going to have a major impact. And some of the research that we're now exploring is in the areas of mitigation within that particular sector, specifically because of these findings. Now, in terms of you know, potential environmental consequences, greenhouse gas emissions are not the only consequence of associated with beef cattle production. There are other particulate emissions as well that can be released, and in this case, ammonia emissions. And ammonia emissions arise primarily from urine. Urine contains a compound called urea, and when that urine is excreted and comes in contact with the soil, there's an enzyme called urease that breaks down the urea and releases the ammonia into the atmosphere. And if under non-acidic conditions, that ammonia becomes volatilized and can move downstream from the point of where it was produced. That can contribute to a reduction in air quality. It can also result in nitrogen deposition downwind from the point of production. When we looked at that amount of emissions, so we did the same thing, we calculated up the amount of ammonia that would be produced from 1981 versus 2011, and we found that over that period of time, there's been a 20% reduction in ammonia emissions as well as a result of improvements in efficiency in the beef industry. So now moving away from the gases, so I emphasize that when we talk about a footprint, we've got to think about more than just the gases. And in this case, so now I'm going to start talking about water. And water obviously is really important for both crop production as well as for beef production in itself as well. But one of the things I really want to emphasize, and this is well known and been proven by several similar analysis to what we did by other laboratories. But basically, when you look at the amount of water that's required to produce beef, 95% of that water that's utilized is associated with feed production. So that's where by far the majority of the water is utilized. Only 5% of the water footprint associated with beef is associated with water that the cattle drink or water that's used in the processing or the retail sectors. So for example, when we're talking our meat processing plants, they use water as part of their cleaning processes, etc. That would be the water that's used with that. When you combine all of those together, it only represents 5% of the beef water footprint. So you'll often see where there's astronomical numbers associated with a amount of water required to produce a kilogram of beef. But you need to think about, really, that water is associated with the production of the feed. So what would happen if beef weren't in that picture? Would that land then just set fallow and wouldn't be used to produce feed or any kind of crops? Probably not. They would be used for some alternative crop production, which would mean that that water would still be utilized in order to produce that crop material, whether it be feed or crops for human consumption. That water is still going to be utilized. So it doesn't make entirely complete sense to allocate all of that water 95%, that 95% figure specifically to beef. Even a more outrageous approach was one where they were documenting grassland ecosystems. So say you had a quarter section of grassland, so that's 160 acres of grassland, and you had a cow in that pasture. Let's say the pasture was unusually large at 160 acres with a single cow, and a rainstorm went over and it rained a bunch on that quarter section. Some of the estimates were taking the water that fell as a result of that rainfall event and assigning it all to the cow in terms of the water that was required, because that pasture was there because that cow was utilizing it. That was their rationale. I was involved in a group called the Livestock Environmental Agricultural Partnership, and I pushed really hard to have that approach completely overturned, and it was successful. The group as a whole agreed to that change, and that change involved then there was a compromise made, and rather than assigning all of the water that's associated with that rainfall event to the quarter section and then to the cow, we were able to convince them that they should only assign the water that's associated with the forage that the cow ate while she was on that pasture. Not all the grass that grew or all the forage that was there that she never consumed. And that is now the foundation for the estimate of the water footprint. It still looks fairly large when you consider that so much of that's coming from the feed. So when we looked at the 1981 versus 2011 comparison, the total water use was declined on a per kilogram of beef by about 17%. And we talk about blue water and green water. Blue water is water that's associated with irrigation or being drawn from ground wells, which is relatively limited in Canada. Most of the irrigation in Canada occurs in Alberta, about 60% of it. And it is a critical factor in terms of our feedlot production area. Pretty well all of the major feedlots in southern Alberta are supported by irrigation systems that produce the crops within the surrounding areas of the feedlot, which are primarily used as forage in the form of barley silage or corn silage that are included in those diets. So irrigation does play a very important role in Alberta. And it's one of the things that, we're looking at too, in terms of when we talk about overall water use and water demand and water quality. And when we consider the things like climate change and what that impact is having, a lot of our water that flows into the prairies originates from glaciers and the eastern slopes of the Rockies. And as those glaciers decline, we need to think about, where is that water going to come from? What are those water demands going to look like? And water availability going to look in the future? So the big question then is, why do we see this positive change? What's responsible for those improvements that we see in all of those metrics that we use to define the hoof print of beef cattle production? Well, the answer is they're multifactorial. Some are related to improvements in reproductive efficiency, so better fertility in the cow, better fertility in the bull, less open cattle, less calves lost through abortions and other means. So an improvement in reproduction efficiency, an increase in weaning weight. Some of that's related to genetics, some of that's related to nutrition as well. Improvements in steer weight, and improvements in heifer weight at slaughter. All of those things were major contributors to the improvements that I just described. Along with that, we see improvements in the crop side of things. So we've seen about a 23% improvement in barley grain yields. That's also going to contribute to increases in barley silage yields. We see an ongoing increasing use, improvements in the efficiency of corn grain and corn silage in terms of their production efficiency. And that continues unabated. Like, everybody thinks that corn will eventually plateau in terms of the increases in yield and productivity that's achievable, but that line just continues to go up. And we've taken advantage of that in Alberta. There's been a large increase in the amount of corn acreage that's being planted in Alberta, especially corn silage for use in corn silage, but we're seeing increasing corn grain as well. As we see climate change, as we see warming, the heat units in Alberta continue to increase, making it more favorable for corn to be grown as a crop source, reducing the risk associated with growing corn because of inclement weather because we've got the heat units now to support that crop. And because the yields are so much higher, they can be as much as twice that of barley. If we can avoid the risk, and we get the heat units we require to sustain that crop, it makes sense. It makes sense to use corn. So what do these findings mean? Well, they mean that Canadian beef producers have not only improved production efficiency, but they've also significantly reduced the environmental footprint per unit of beef. And I think it's important to emphasize that those improvements were going on long before we were talking about climate change. In 1981, there wasn't a lot of information about climate change going on. Those producers were also making those improvements in efficiency because it was both economically desirable to do so, and there were animal welfare and health benefits as well as associated with those changes. I emphasize that the cow-calf system accounted for most of the methane emissions, and that's a major area that's being focused on now for opportunities for mitigation. And really, it's finding a balance between production efficiency and the benefits of grazing and reducing the environmental footprint. So since that original studies that were done over a course of 5 years, you can see how we established a substantial baseline for us to continue to do work in this area. And what we've done is we've got active research programs going on right now where we've broadened that perspective even beyond what I've just described there, moving into other aspects of ecosystem services, which includes the carbon sequestration in the grasslands, but also contributions in terms of aesthetic value, maintenance of grassland systems, the importance that beef have in water and nutrient recycling. When we look at the comparing of agriculture systems, if we look at the beef system, if we're talking the cow-calf sector where they're out on extensive rangelands, those sloughs and ponds that are in those rangelands are maintained as water sources and represent rich ecosystems for aquatic life, both bird life as well as fish and other insects. And at the same time, they also represent another site for carbon sequestration. If we compare that to cropland-based systems where the alternative protein sources are growing, typically in those areas when they're cultivated, that represents a massive release of carbon as a result of the breakup of that grassland. And on top of that, those ecosystems, wetland ecosystems, are typically drained using tile drainage or other means, and cultivated as well and used to produce those alternative protein sources. So we need to recognize those trade-offs, and that's something that we're doing now when we broaden the approach to other ecosystem services. The other thing that we want to look at is the role of beef in a sustainable agriculture from the perspective of a circular economy. And we have to recognize that beef production in itself provides more than just meat. When we look at leather, bone meal, number of different pharmaceuticals, there's products that go into pharmaceuticals. There's well over 200 different byproducts that arise as a result of the processing and the use of the various components of the carcass from beef cattle. At the same time, they produce manure. That manure then can be a source of energy going into biorefineries. So we have a biodigestion plant down here in Lethbridge that produces electricity from manure that's hauled from the feedlots to produce methane, which is then converted to electricity using a generator. In addition to that, that manure represents a significant source of fertilizer that can be used to promote crop production. And unlike chemical fertilizer, manure has organic matter in it. So we always hear about how, well, cultivation and crop production has lowered the organic matter content of our soils. Well, by adding chemical fertilizer, when we add chemically produced fertilizer that arises from the use of fossil fuels, we do not directly add organic matter back to those soils. Manure itself has carbon in it. It has organic matter. So just by the very act of adding manure to a soil, you're going to automatically increase and help restore that organic matter content. It also has a range of slow release carbon and nitrogen components within it as well that can also help promote crop productivity and soil health. So we need to recognize that as well, whether that's being deposited on pasture or spread on cropland. And the other thing we needed to consider, especially when it came to our greenhouse gas emissions, is that there's a carbon dioxide release associated with the use of mineral fertilizer because we need fossil fuels to produce those fertilizers relative to manure, which has those nutrients directly in it to help improve soil quality. And those then can all lead to improved plant production, crop production. I think we've all saw, we even can see that in our own lawns at home if we're in urbans, where we see where the neighbor's dog went wee-wee on the grass, and we see that that particular area is greener than what the area is that wasn't fertilized as a result of that nitrogen source. So that's a very important thing to realize. The other thing to realize is that a lot of the feeds that are provided to the beef cattle, and especially in feedlots, are actually bioproducts from the agri-food industry. Probably the best example of that would be things like the barley grain that we feed and the wheat that we feed in the feedlots. In many cases, that represents barley that did not make the grade that would be suitable for malting purposes, or wheat that did not meet the grade that was suitable for the production of flour. Those byproducts have value because we have a livestock industry, and they can be used as feed and converted, really a form of value added by converting those into meat products, whether they be beef, poultry, or swine. And we need to realize that without those markets, those byproducts, which did not meet the grade for human consumption, would essentially then become a liability, and the industry would have to dispose of them somehow. Now, maybe they could put them through a biodigester or something like that, but I would be hazard to guess that the economics of that would not be as favorable as putting it through the livestock production system like it is today. So that's why we need to think of those trade-offs and how that circular economy works, and why livestock play a critical role within that economy. The other is related to the benefits of forage and ruminant systems, and that's really looking at grasslands and forage lands, which provide ecosystems benefits in terms of animal welfare, plant diversity, wildlife habitat, watershed management, the soil erosion control, preventing invasive species from entering into those areas, and a reduction in fossil fuel energy because they're more extensive systems. They don't rely on the use of fossil fuels as much for the harvest of those forages that are produced naturally as a result of photosynthesis and carbon sequestration. And we need to recognize that those ecosystems actually represent some of the most endangered ecosystems on the planet. We always hear about how they're chopping down the rainforest and those kinds of things, but the native grasslands of North America are even more endangered than when we look at the rainforests of the Amazon in terms of the destruction that's taken place. Those ecosystems today represent or house 60 of the species that are at risk within Canada and are already 75% depleted. So many of the species like the sage grouse, the black-footed ferret, the swift fox, of which there's been major programs to try to sustain and prevent extinction, are within those very important ecosystems. The other thing is that area is also being looked at to some extent as the savior for the climate change issue. There's a huge global effort that's underway to recognize grasslands for the carbon that they sequester and the carbon that they store. And there's a hope that that will represent a major store or sequestration pool that can be taken upon going through into the future. In various regions of the world, many of the grasslands have been depleted and are in poor shape. And there's a feel that if they can improve management practices, they can improve carbon sequestration and storage in those areas, and that can help deal with climate change. In the Paris Accord, that was one of the primary solutions that were put forward as a method of helping meet the targets to maintain the reduction in temperature increase targets. So I think there's significant momentum here. And, in the last 10 to 15 years ago, so there's been a major shift and a coming together of individual organizations from across society. And, I think if you went back 15 or 20 years ago, one of the major initiatives is what they call the Global Roundtable for Sustainable Beef Production. And the Canadian Roundtable for Sustainable Beef Production is one of the most active groups within that overall organization. And I think if you look back 15 or 20 years ago, probably people wouldn't believe that you would have organizations like the Canadian Cattlemen's Association and Beef USA and other producer groups sitting around the table with organizations like the World Wildlife Fund, the Rainforest Alliance, and others, along with the major manufacturing and retail and pharmaceutical industries, sitting around the table and trying to develop solutions. And I think that that was a key change that we've seen, and it's really led to some of the openness and willingness to address these issues head on, is because these kinds of organizations were established and they started to sit around the table and started to work together towards a common solution and really recognizing those trade-offs. You know, if you want to understand the trade-offs, you have to have people at the table that understand both sides of the issue. That's how you can define those trade-offs and develop solutions. And that's what the Global Roundtable for Sustainable Beef and the Canadian Roundtable for Sustainable Beef is extremely active in doing that within Canada. And then I've been involved, a lot of the work that I outlined there and the methods and, you know, the experiences that we brought to apply to Canada also originated from an organization that's ran out of the United Nations and FAO called the LEAP Environmental Assessment and Performance Partnership Organization. It's a similar organization, but it takes the perspective from a global level. So it's looking at global livestock production. And obviously that differs dramatically depending upon the ecosystems you're talking about. Agriculture, beef production in Brazil is quite different than agriculture and beef production in Canada. So you need solutions that are regionally or locally suitable in order to understand these trade-offs and develop solutions. And this is a similar organization. So I served on the greenhouse gas component, large ruminant guidelines that were developed for this. The water use and water impact guidelines were developed from this. And most recently, just yesterday, we announced the release of the guidelines for the biodiversity and studying, basically quantifying the relationship between biodiversity and livestock production. And those were just released by LEAP yesterday to the world after peer review. And I was lucky enough to serve as the chair of that committee, which was a great honor and a huge learning experience. So with that, I want to thank everybody for the opportunity here today. And I also want to recognize and really emphasize strongly, I think I did a few times already, is that this really was a massive team effort. You know, there is no scientist that can address all these issues, can really understand the complexities of the systems we're talking about here. It really involves getting people around a table from various expertises, discussing, talking, you know, and sometimes we're forced to make assumptions. There's, you know, all the data is not there, but when you can have those people that are on both sides of the issues, those trade-offs I talked about, and you can propose a solution or an approach to that data gap, it makes you that much more confident in the value of that estimate, and that it's realistic in terms of developing solutions for these issues. So with that, thank you very much, and I'll return it back to Alexis.
Thanks so much, Tim. We've got several questions coming in. And one of the first questions that we have is, can you comment on how you think we can transform the ideas presented in this paper into reality?
Well, you know, I think we're seeing some of that already. We're seeing recognition, you know, I think within the beef industry as a whole, and even within society, about the importance of the grassland ecosystems. You know, there's been a number of initiatives. We just had the release of Guardians of the Grasslands, which I think is a really outstanding movie that shows, you know, the role that beef cattle play. We need people to realize, you know, that beef cattle are, you know, for the most part, largely replacing the role that bison played on the plains pre-European time, right? Some of it's changed because we have fences that restrict their movement a little bit and things like that. But there's no doubt that when we talk about these ecosystems, grassland ecosystems, they're much better to have grazers within those ecosystems than them excluded. And so, you know, those kinds of awarenesses, I think, are part of working towards developing that adoption. But, you know, part of it is just informing the consumers and society as a whole, as I outlined at the start of my presentation, that they need to understand the trade-offs. Like, there's lots of advantages in terms of biodiversity and the grassland ecosystem, but when it comes to productive efficiency, we need that combination system because we can finish the animals that much faster in a feedlot with lower emissions and produce, quality beef that really meets export markets as well. So it's really about a balancing act. And I think that's one of the things that makes the Canadian system so efficient. It really is a combination of those, as I outlined in the complexity of the beef cattle production, that complexity also contributes to its high efficiency.
Yeah. So some questions we have we have two questions that are very similar. So I'm going to ask them, like they're kind of linked together. So I'm going to ask them at once. How are we linking beef production to supplying a quality pursuit product to consumers? Like, how are we linking those two together? That's the first part of the question. And then is, how do we brand Canadian beef produced in the sustainable way to differentiate in the marketplace?
Well, those are good questions. Like, we have a grading system in place. We have metrics in place that measure meat quality, and breeding programs in that, working towards achieving a consistent product. That's been one of the challenges in the beef industry, and I really think we've made great strides in overcoming that. Still some work to be done, but one of the issues, if you look at the difference between beef cattle production and, say, poultry production, when we look at broiler production, broilers are produced in the same barn, very much the same conditions, same temperature, same humidity. Part of the equation of producing broilers efficiency is keeping all those things constant. When we talk about beef cattle, that doesn't work for beef cattle, because we produce beef cattle in northern Alberta and we produce beef cattle in southern Alberta. And those environments are incredibly different. We need genetics that can be efficient in both of those environments. And that leads to diversity. That's why we need diverse cattle populations. And that then can contribute to diversity in the meat as well, because genetic diversity and environmental adaptation can also result in genetic diversity within the meat. But I think with a lot of our crossbreeding programs and that, and with the grading systems that are in place, we've really worked towards improving the consistency of the steak you buy in the grocery store. And now you go, 99% of the time you go and you buy a good quality, the right cut of steak, and cook it in the right manner, you'll get a much more consistent quality steak than you would have 25 years ago. Mm-hmm. And that's a big difference. Can you remind me of the second question?
The second question was about, how do we brand Canadian beef produced in a sustainable?
Yeah, that's another really interesting question. Yeah, I had an idea about that. I don't know how far it would go, but when we had COOL, country of origin labeling, right? I thought there might have been an opportunity there to label that as Canadian beef and be proud of it. Emphasize the Canadian Rockies, emphasize our eastern slopes, emphasize our grassland-based systems that we have. Emphasize what Canada has and what is unique. I don't know, we call 1-4, down in the southern area. That's probably some of our driest pasture land that we have in all of Canada. Maybe out in Osoyoos in that area, it might be a bit drier. But if you look at that land, we call that dry, low stocking grassland. Mm-hmm. But if you go down into Arizona or New Mexico or any of those, you want to see like dry, barren ground with, which looks like horrible for raising livestock compared to what we have. I think there were components there that we could have used to try to emphasize, these are the characteristics of Canada. This is what is about our environment that enables us to produce amongst the highest quality beef in the world. Whether that would have worked or not, it would have been interesting to have done some pilot scale stuff or something. I wouldn't want to roll in with the entire export of the Canadian beef industry on an idea like that. But I think it would have been interesting to have tried that or trialed that in some localized areas in the United States to just see how much that cost, because lots of Americans come up here because of our mountains, because of our glaciers, because of our water and our rivers, right? So maybe we could have capitalized on that. And, they're still pushing to bring COOL back, so maybe there'll still be an opportunity in the future.
So our time is actually up, so we can stay on. And if anyone has to go, it's actually 3:50. But if anyone wants to stay on, we can continue asking questions. I just want to say, before anyone logs off, our next webinar will be tomorrow, Wednesday, June 24th at 3. I'll be moderating a session with Karen Holzer, and her presentation will be Antibiotics in Animals, Improving Canada's Meat Supply and Exports. But we do have a few more questions if people would like to stay on, so I can ask you a few more questions,
Sure.
Tim. So in Canada, how much improvement can we target for carbon sequestration in our grasslands? Is there any math to go with that? Is this a finite number, and how far along are we to date?
Well, I think it's really important that we differentiate between carbon sequestration and carbon storage. So carbon storage is the carbon that's already in those grasslands. We want to sustain that at all costs because we know for sure if we cultivate up that grassland, we're going to release that carbon into the atmosphere. You know, there's debate now in the science with regard to whether the carbon is continuously sequestered and deposited in the grassland ecosystems or whether it reaches a plateau over a fixed period of time. The problem with a lot of those theories is that we don't have sufficient lengths of time that we've measured that. I think the longest of that measurements that have been actively made is in the vicinity of 100 to 150 years. We need to make those measurements over a period of 500 to 1,000 years to be able to accurately, you know, really know which way that carbon's going. We're very sure that if we cultivate it up, we lose it, but we're not sure how quickly we gain it back. And a lot of that is going to be dependent on climate as well. So individual changes in weather, you know, it's really important to differentiate between climate and weather. They're not the same thing. And some years we can have dry years. That's not necessarily climate, that's more weather, right? And in a dry year where you don't have a lot of rainfall, if you don't have any rainfall, you don't have a lot of photosynthesis, you don't get a lot of carbon sequestration. So if you have alternate years of where you have a really rainy year, lots of photosynthesis taking place, lots of carbon is deposited, followed by a dry year where there is no photosynthesis, you could lose that carbon in the following year or a large portion of it that you sequestered in the previous year. That's why you need 500 years of measurements, you know, to have all of that variability taken into consideration so you can see that overall trend. I was quite interested when I went to, I was in Ireland not too long ago, and they're telling us how they continuously sequester carbon in their grasslands. And I said, well, how do you know that that's not just a short-term thing you're measuring and not a long-term thing? And they said, well, because it's always happened ever since we measured them. And I said, well, what was on here 500 years ago? It was all forest. You know, they chopped down, they chopped the forest down.
Yeah.
They call it grassland, but it was forest. So what was the impact of that? We could still be seeing impacts in that ecosystem as a result of that forest that was removed 500 years ago that's still impacting the trend that they're seeing. You know, so it's really difficult to make those types of biological measurements that take place over an extremely long period of time within the time that we've been making those kinds of measurements.
Yeah, so this is a question from like a participant, and also I have this question as well, is why does this message about sustainable beef and sustainable beef production not get out to the public? And so this question asker wants to know what's happening to get this message out to the general public, and especially to get it into the school system.
Yeah, well, there are programs in place, you know, agriculture in the classroom, which I think is a great idea. I think that that's a really important thing to, you know, we want to make sure that the younger generation recognizes the importance of food. You know, I think COVID-19 woke up society a little bit to that when people went into the grocery stores and found that there wasn't all the food that they expected to be on the shelves. That was a real big wake-up call, you know, and then we had people planting gardens and all of that. I think that's all great for people to have an appreciation for their food and realize where food comes from, and that it's not always easy to produce that food either. So that type of education in the classroom, I think, is a really important program. Getting, you know, kids out to the farming systems, understanding agricultural, some of the system stuff that I just described, you know, both on the crop side and on the livestock side would be important. And the use of social media, I think, is another area, you know, Twitter, all the various Facebook, et cetera, that are available to try to get that message out. You know, when I talked about those, you know, I think in the past that small boisterous group that usually is often not representing the majority, but is very strong in producing its position, have really gained a lot of traction in terms of influencing society because of those social media tools that exist. And, you know, part of the challenges, you know, I talked about scientific integrity. We're bound by scientific integrity. You know, we just can't make things up, right? Those people can. They can make up whatever they want. They don't have any bounds in terms of their integrity.
Yeah.
So that, you know, they just, and that's kind of a disadvantage that we have, you know. Obviously we need to do that to maintain our credibility, and we're going to continue to do that. But it does put us at a disadvantage in terms of we don't make things up, you know.
So my other question is, I was just thinking when you were describing the whole life cycle of beef and the whole process, if you might not know this at this point, but I'm just wondering if any scientists have looked into this, if COVID-19 is going to have an impact on the, you know, the beef, the footprint, because there's now increased sanitation and so on. Will that also increase the footprint of beef?
Well, I think probably the largest impact of COVID-19 in general has been the reduction in the use of fossil fuels, you know, which we've seen in terms of use in transportation, or just the use of our personal vehicles, et cetera, the less traveling to work, all those kinds of things, is, you know, and we've heard about that internationally, about how you hear about some of the major cities in the world where people are waking up and they don't realize that that mountain range ever existed, that they can now see because the pollution around the city has declined. So it's had a huge impact like that. You know, the biggest impact in the beef industry was related to our processing plants and the problems that we had with the outbreaks in the plants, which I think are, you know, the plants were very responsive, the employees were responsive, and everybody worked very hard to overcome that, to get those plants back online. I'm not sure if they're still at full capacity or not, but there was a lot of steps that were taken there. But I think, you know, I didn't say too much about COVID, but when it comes to COVID and dealing with that issue, we need to take the same approach. We need to look at it from a systems perspective.
Yeah.
And there's always the opportunity, you know, out of heartache comes opportunity as well. And there's the opportunity for transformation to occur now. And I think some of that's happened. I think there's a greater appreciation now for Canadian agriculture and agriculture producers, and in terms of the contribution that they make to Canadian society. That's been a positive that's come out of that. We've heard a greater appreciation for biodiversity. You know, you hear the reports of wildlife being found in cities and in areas where people hadn't ever seen them before. And, you know, that biodiversity that's largely hidden when everything's going full tilt. And then, you know, I think the biggest thing when we talk about land use change and that from the biodiversity perspective is the issues that could have led to COVID in the first place. You know, the destruction of habitats, of where wildlife was existing in greater contact with urban centers and humans, and the opportunity for transmission of these zoonotic diseases. We really haven't seen too much of that arise directly in North America. Most of it seems to originate in more densely populated areas and in areas that are closer to rainforest or jungle areas where both biodiversity is quite high. You know, but that doesn't mean that it couldn't occur in other areas of the world as well. So I think that's something we need to be cognizant of as well. And beef plays you know, a huge area. If we're going to save the native grasslands of North America, beef has a role in that. There's just no doubt about that.
Okay, so this is I can say one thing that I know just from like a call I did a while ago, is that I think one of the plants is up in Alberta, one of the plants is up to 95% capacity, and the other two are up to 100%. So we do have all our capacity back up, and also out in central Canada, the capacity is also back up there too. So at this point, we are running at a pretty good capacity, even though there's still a backlog of cattle and a lot of worry about what's going to happen when.
One of the questions I had was about, like, that was emailed to me, was about whether we should go to smaller, you know, local plants and that. And I think that, you know, we don't want to discourage that if the economics are such that they promote that kind of development, because, you know, part of sustainability is also having a high level of diversity. So, you know, those kinds of plants could serve the local, you know, within 100-mile radius type of people who want to consume beef that's locally produced. They definitely could have, you know, the grass-fed sector has a good opportunity to work with those smaller plants and brand their products on an individual farm basis. You know, those all make good sense, and they make really good sense for local markets. And, you know, basically the beef industry has to meet the demands of the consumer, whatever they may be. But it's probably not practical to look at that approach to maintain our export markets and continue to move the kind of beef that we do to the United States or to Japan or Korea or you know, into the Middle East. We still need that intensive side of the system to deliver on that side of the equation as well.
Yeah, definitely. Well, I'm sorry that's all the time we have left for today, but this has been a fascinating conversation, and I could personally continue it for a long time because it's a topic near and dear to my heart. But thank you so much, Tim, and everyone else. Thank you for coming. And tomorrow's webinar is at 3 o'clock with Dr. Carolyn Holzer, and more talk about antibiotics in animals.
Yeah, thanks a lot. I had my email there on my last slide. So if anybody has additional questions, please just email me and I'll respond to them.
Tim's email will also be included in the wrap-up notes if anyone has any questions for him to continue the conversation, because I know this is a very important topic.
Thanks
so
very much.
Tim.
Thanks very much, guys. Bye. Have a good day.